Now we have seen the problem that we have solved in this one, that we have taken hybrid inheritance. We have started with class A, and from class A we have inherited uh, class B. Okay, and after that we have inherited class D. So this is a example of hybrid inheritance, okay, where we are inheriting from one class to another. So it looks something like this. Okay, so we have class A. Okay, from class A we have derived class B. From class B we have derived class Z, and so on. Okay, now this almost looks like a diamond, so this is called a diamond problem. So what is the problem? To understand the problem, let's go to do and see the code. So this is our code. Okay, so what we did here, let me so first we have declared a derived a class A, and the class A we have a function called show, which prints hello from A. Nothing, very simple, right? And after that you have another class called class B. Okay, in the class B we don't have anything, and then we have another class that is called class C. In the class C we also don't have anything. Okay, now after that we have a class D, which inherits both class B and C. So we can say, so this is class A. So this is our base class, class A. From class A we're deriving class B and class C, and from B and C we're deriving class D. I hope we're clear so far. Now if we go back, so we have created these classes, and from these classes we have derived two other classes, and so on. So from class A is our base class, from here we have B and C, and from B and C we have class D. Now to go back to our code, in the main function what we did, okay, we didn't write anything. Okay, so all of these classes we didn't write any other definition. Now whenever we start executing the program, we create an object of class D, and for the class D object we call the show function. Now we know that whenever we do the inheritance, this code of the uh, parent class is getting copied to class B. So class B also have a show function. Then this class C is also inheriting class A, so it also has a show function, or it can call the show function. And then class D, which inherits B and C, it also have a show function. Now the problem starts from there. Okay, so if I try to first run the program, you see object should have a show function, right? Because this is in the class D. So you see the program will not run, it's showing an error. So what is the error? Let me just show you here. So if you see that the error is that candidates a dot show, okay, request for member show is ambiguous. So what does this error mean? Request for member show is ambiguous. So what does this one actually means? That whenever I am calling this function, show function, ambiguous means the compiler cannot understand. What does this mean? So why the compiler would not be able to understand? Because I have specifically said call the show function. Same way I have specifically said call the sum function. So they didn't have any problem here calling the sum function, but here they are having problem with the show function. The answer is, to understand the answer, we have to again go back to this picture. So initially we had only base class where we had only show function. And after this, we didn't create any other. We have created two classes, but we didn't write any definition. So that means this show class is available in this derived class 1. That was our class B. Let me just write it in this way. Class B have a show class. Class C also have a show class. Where did this class C got its show class? It's got it from A. From A. So show from A. Show class, show function, sorry, not a class, show function in A. So these two classes, derived class 1 that is B and derived class C, that also got this show from A. Okay, now when we have reached the derived class 3, as you can see, we have derived for public class B and public class C. So if I go back to this picture, that means this derived function, which is the name is D, have show class because it's derived from both B and C, has two show function from B. It has a show function from C, and those B and C both come from A. Now the compiler gets confused because you are telling him to call the show function, and it has a show function that comes from A in B. It has another show function that also in C, but that also comes from A. So basically, the show function that is in C comes from A. We know that. So this show function comes from A. This show function also comes from A. So whenever the compiler inherits these two classes, okay, it also get the show function from A in both cases. So now it has now two show function. One came from this way, okay, from A to B, B to D. Another came from this way. So it has now two show function, and it gets confused that, okay, I have two show function. One came in this way from derived class, another came in this way. So which show function should I call? Okay, and you see the data is getting repeated. This is just one simple example. It can happen for code that is larger than this. So you see we didn't write anything here, okay, and it's getting confused. So which show function to call? And that is called a diamond problem. And to solve that, we use virtual inheritance. So today I will answer that what is a virtual inheritance, how it solves the diamond problem. Okay, to understand that, let's see the next code. Okay, so next code is also same. We have class A. In the class A, we also have a member variable that is integer A, and we have a constructor A10. Then instead of writing in this one, we inherited just using public A, public B. To use the virtual keyword, what we will do, we'll add just virtual here before public. Okay, just like this, we will add virtual keyword before the public. So here, as you can see, public virtual A and public virtual A. So in both cases, we have added virtual. The keyword, so this is a keyword virtual. Okay, we will add this in both cases. After that, we will try to do the same operation. Okay, so let's start from this one. Okay, the one that we started first. So we had this, let me just, yeah. So the first problem one here, we had this show function. We are inheriting from both public A, public in case of class B and class C. And after that, we have inherited in class D. And when we're trying to run the program, the problem was it was showing that request for member show is ambiguous. I cannot understand which show to call. So how did we solve it? Okay, to solve that one, we added the keyword virtual in front of with all the inheritance. So public B and public class C both have added, we would added virtual. Now after, when we do this, okay, and try to run the program, you see rest of the program is same, just I added this virtual here. Okay, now if I try to run the program, you see now it's saying hello from A. So now it means it's not confused anymore. The problem that we faced in this program is not here anymore. And how did we solve it? Just by using this small word that is called virtual. So now we have to understand that how this small virtual word actually helps us. So we'll go to that. But before that, let's see this example. So here, this is another example. You have an integer A with a constructor. Okay. So whenever we call this function public virtual A, public virtual for both classes, we want to see that which constructor gets called. Or like as we have two constructor, it might get confusing for the compiler. Same way that it did in the other cases. So as you will see that in this case, as soon as we use the virtual keyword, we don't get confused. The compiler starts with creating an object of D, and then it calls A equals to object dot A. Now object dot A, so A is a public variable that belongs to public class B and C. But as we're using the virtual keyword, it will not get confused. One more time, why we use this virtual keyword? Because we face a diamond problem. What is a diamond problem? If we have a function or a variable, it can be a function or it can be a variable, okay, in base class, and then we do the derivation for two separate classes. So far good. But then from these two separate classes, if we derive another class, okay, so it creates a problem called diamond problem. Okay, so what is the diamond problem? The diamond problem is the compiler get confused. Why the compiler get confused? Because let's assume I have a variable named variable a and function. Okay, let's name the variable x and the function show. This is in class A. Let's name this class A. Okay. Mm, so this is the first case. Now from this class A, we derive class B. Okay. So we have variable x and function show from A. So in this case, as we derive, we will have a x and show function from A. Same goes for this one. In the class C, we also have x and function show from A. So far it's good. Okay, it's not a problem. The problem is just when we do this. Okay, now this, let's assume this is class D. Class D have two variable x and two function show, and it gets actually totally confused that which one to call. And to solve this problem, what we do, we actually use the virtual inheritance. Now let's go back to our code. So just adding, so this was the program that was having a problem. So what we did, we just added virtual keyword after the public. So just by doing that, we can solve the problem. So now we know how to solve the problem. But the question remains that what role this virtual keyword actually plays? Because here is another example where we can solve the problem. So now we have to answer that how it actually solves the problem. We know that it solves it, but we have to also understand how it solves it. So we're saying that how we can solve this. So in the slide, as you can see, there are two ways we can solve it. We can do by manual selection, or we can use the virtual base class. So I have already shown you how to use the virtual base class. Let me show you how to do the manual selection. Okay, so to do that, what we can do, we can actually specify that select a specific class, a specific function. For example, in this one, you see this is a class where we have two classes, 2 and 3. Both are having the same problem in class 2 and class 3. So what we do, okay, to make things easy for us, we first create the object of 4, that is our D class in the example that I was discussing. So 4 is basically D, and F is basically show function. Okay, sorry, it's not a function, it's the object. So D is a class here and F is an object. So what we do, we write F dot 2 is basically B, and then we may specify A. So in our example that we have shown, if I so first it was D class, okay, and then we can say that sorry, the object was, I forgot what is the object. Let's name the object is object. Okay, so object dot, so as the compiler is confused which function to call, we'll say that okay, go for B. Okay, then in the B, call the show function. So we'll write in this way. Okay, in this way the compiler will understand that okay, for this object I will go to the class B and then I will call the show function. Okay, for the variable it's almost like okay, for this object I will go to B class and I will call the variable X. So even if we have two variables or two functions or multiple variables, multiple functions, we can write like this and it will solve the problem. Okay, so this is called my manual selection. Now let's go for the next one. So in this way, we can and this is the virtual word that we have just shown. So virtual, you can write it before the public or after the public, it actually doesn't matter that much. Okay, as soon as you write, okay, what the compiler will do, whenever you write this word virtual, okay, it will understand that okay, for this one there can be multiple instances or there can be a diamond problem. Let me go back here. Yes, so there can be multiple variables or multiple functions for the same name, so I have to maintain at least one. So lastly, let's explain with this example. So this is a class called class 1, this is the class 2 that comes from class 1, this is a class 3 also comes from class 1, and this is a class 4 that comes from 2 and 3. So same example that we did, class A, from class A we have class B and C, and from class B and C we have class 4. Okay, now whenever we actually starts with this, okay, integer 4f, it calls the constructor. Okay, and in the constructor, as you can see, that what we do, we actually run 1 prints 1, 2 prints 2, 3 prints 3, and 4 prints 4. So as soon as I type 4f, what it does, it actually calls all the constructors. And you will see that whenever it's calling all the constructor of the class 1, that is this one, or the class A in our example, is getting called twice. So you see, class 1 is getting called twice. So this is a problem, right? Two copies of the same class, that is one. So when we use the virtual keyword, or what happens, the virtual base class, okay, we add this virtual word, and after that, if you run the same program, okay, you will see that's only one copy will be maintained. There will be no ambiguity. So that's how the virtual keyword solves the problem. So what it does, it maintains one single copy. Okay, it understands that yes, okay, as you have used the virtual keyword, that means there can be multiple copy with the same name. So using one, okay, what you will do, it will actually make sure that there is no ambiguity.